All right, so now that we've got the basics of forces and motion down, we kind of understand how they work. I want to talk about Isaac Newton and his three laws of motion and how we know how all of this works. So, Isaac Newton was a very famous physicist. And of course, the story goes that he was sitting under a tree one day and an apple fell on his head, and there was no wind to push it off. He didn't pull it off. So, his question was, how did it fall? Why did it fall? He knew there had to be a force that was pulling it, but he didn't know what that force was. And then that got him curious, and it led to him discovering gravity. Now, whether or not the Apple story is true, I don't know, but it is true that he got very interested in forces in motion and how and why things moved, and he discovered gravity, and he also came up with these three rules, these three laws for how motion works. And everything that's moving follows these three laws, which is really helpful for us because it can help us predict how things are going to move in the future. It can help us engineer things like airplanes and rockets, and it can help us plan for things like driving. So, we already know that a force is a push or a pull. It's any action that's able to change motion. If you push or pull something, if you apply a force to something, you could possibly change either its speed or its direction. So Newton's first law is the law of inertia. And I'm sure you've heard this before. It says that objects continue the motion they already have unless they are acted upon by a net force. So this law says, and this is the part that's going to sound really familiar to you, objects in motion stay in motion. Objects at rest stay at rest unless acted upon by a force. And all that really means is things want to keep doing what they're doing. If something is already moving, it wants to keep moving forever and ever and ever. And if something is just sitting still, it wants to stay still forever and ever and ever. And the only way to change that, the only way to make something move, or if it's already moving, the only way to make it stop, the only way to change what it's doing is by applying a force. So if the net force is zero, then you're not going to change anything, right? If the net force is zero, it's just going to sit there. But if the object is acted upon by unbalanced forces, a greater force than what's already acting on it, then its motion is going to change. So this is what I just said, Newton's first law. Object at rest will stay at rest. Objects in motion will stay in motion unless there is a net force. So playing golf. That golf ball sitting on the golf tee is not moving. It doesn't want to move. Inertia. It has inertia. And because it has inertia, it's never ever going to move until an outside force moves it. It will never move on its own. So what's the outside force that's going to move it? You hitting it with a golf club. When the golf club hits it, that creates an unbalanced force that will make it move. A water bottle sitting on your desk will never ever move unless a force outside of the water bottle moves it, like your hand as you pick it up. So forces can either make something move faster, or it can slow something down and stop it, or it can simply change the direction of the object. But all of those are considered part of this first law. Forces, any kind of force that can change any part of the motion. So inertia is actually a property that objects have. Inertia tells us how hard it is to make them change because some things, nothing wants to change. Objects want to keep doing what they're doing, but it's easier to change some than others. So objects that have a greater mass have more inertia and are therefore harder to move. You have to apply more force to get them to change. So for example, a golf ball versus a bowling ball. The golf ball is tiny, right? It's very light. The bowling ball is bigger. It's heavier. It's going to take more force. If I just push them, it's going to take more force for me to be able to push the bowling ball. Because the bowling ball is bigger, it has more inertia. It really wants to keep doing what it's doing, and it's going to take a lot of force to move it. The golf ball is smaller. It has a little bit of inertia. It wants to keep doing what it's doing, but it's only going to take a little bit of force for me to move it because it only has a little bit of inertia. So the bigger things are, the more inertia they have, the harder you have to push or pull to make them change. And this is just one more way of saying Newton's first law. So I'll let you pause if you want to and read that, but it says the same thing we've been talking about. And that's it. Newton's first law is pretty quick and easy, right? Okay, so we're going to do a lab about Newton's first law tomorrow where we kind of play around with some things and demonstrate how this works. So before we do that lab, I'm going to need you, just like always, to either have your notes filled out or to go ahead and send me a question that you have over Newton's first law, something maybe about the vocabulary, a question you have about what if this happened. Whatever your question is, go ahead and send that in, and then I will see you guys for the lab tomorrow. Bye.